So good morning, everybody. I'm Giuliano Boni from Vinidea, and I'll be the moderator of this webinar. The webinar will be broadcasted in English, but you can be able to see the translation in your own language. For Italian-speaking people, the translation will be selecting the Chinese flag, the Chinese icon, because Zoom doesn't provide yet our language as default. For Spanish people or French people, they just to have to select their own flag and they'll be able to hear the translation in their own language. For all the rest of the world, we have English as a common language. I will show you quickly how to interact with the speakers today, which will be, as introduction, George Beer from Wageningen University and Research, Jovana Vlaškalin from Biosense Institute of Novi Sad in Serbia, and my colleague Gianni Trioli from Vinidea, Italy. And the introduction will be followed by the presentation of several speakers. I'll introduce them later at the right time. So I'll ask George, Jovana, and Gianni to switch on their cameras and their microphones to say hello. And I'll tell you that only speakers have allowed are allowed to use a microphone and a video. So all the attendants, please use the Q&A text box to type your question or type your needs to communicate with the staff. If you have any connection doubt, do it now. If you have any question for the speaker, please wait for the end of the webinar, so after 6 p.m. and we will concentrate all the Q&A section at the end. So help also us to address the question to the right speaker, typing also the name of the speaker or the company or the technology you are using for. Don't forget that all these recordings will be available later on InfoWine, our technical grape and wine magazine on the net in 6 languages. And most of the speeches today and most of the application of the internet project, Internet of Food and Farms, will be also presented at big congresses scheduled for the next year, starting from a new forum web conference and keeping the finger crossed, also physical forum in May in California, later in Vicenza, and also InfoWine Forum in Portugal. So I ask George, Gianni, and Jovana to switch their camera on and to introduce this conference.
Okay, thanks, Giuliano. Yeah, it's a real pleasure for me to welcome all of you. I'm a coordinator of the IOF project, in which we are we have collected 33 use cases working on IoT for agri-food. And it's, though my name is Beers, I'm very proud to be part of this wine and grape session, because the grape and the wine cases in the IOF project have done great achievements, impressive innovations, and very beneficial solutions they developed in the cases. and that will benefit the sector, and I think also for society. These are impressive achievements. So I'm very proud of that. I'm very happy to see that that this is now presented in a cooperation between the different cases, because what I see and what really strikes me very deep is the development of new partnerships, new ways of cooperation, just a cooperation across the use cases. And this webinar is a good example of that. Developing a network, developing cooperations, partnerships is an important objective of the IOF 2020 project. And I'm sure that now the project is in its final stage, but I'm pretty sure that the partnerships will continue. So it's great to be with you in this this webinar, to listen and to look at the results of the grape and wine cases, and I'm very curious to see what your activities have delivered, and I'm looking forward that a lot of participants in this this webinar will take over and will continue working on the results that are presented today. Thank you, and I now hand over to Giovanna.
Thank you very much, George, and good evening from my side as well.
You can share your screen, Giovanna.
Yes, indeed. Should be fine now. Yeah?
Yes, great.
Okay, great. So my name is Giovanna, and I'm coming from Biosense Institute based in Novi Sad, Serbia. Biosense is one of the partners within the project, leading the monitoring of use cases. And I wanted to give you just a bit overview of what the IOF 2020 is, to have a bit wider picture of today's demonstration and to understand what we are doing within the project. So the project in brief is Horizon 2020 large-scale pilot. It started 4 years ago, and it's ending in March 2021. So we are very nearly at the end of the project. And so we are wrapping up our results and very proud to present today's use cases with their very good examples of IOF 2020 results. So we have 120 partners in 22 countries and 30 million of the EU contribution for the project. So the project is looking at different IoT technologies within the European food and farming industry. And we're looking at these technologies from different perspectives. So this is the business case of Internet of Things. Then integrating IoT technologies by exploring infrastructures and standards. Then, of course, communicating to users, which are mostly farmers, including their needs, which is very important for the feedback and further improvement of the solution. And then ensuring sustainability beyond the project. And therefore, as the project is ending, the network will be, let's say, switched to another Horizon project, which is Smart Agri-Hubs. And you're also very much invited to look at the web of the Smart Agri-Hubs project, where we're also working with the within the ecosystem and the application of new technologies within different fields. As it was also mentioned, so we have 33 use cases across Europe, and there is a map of Europe here. You can see these dots depending on the trial. There is arable trial, fruits, dairy, vegetables, and meat. So 33 altogether. So you can see how they're spread across. And today we'll hear about solutions mostly from the fruit trial. We have fresh table grape chain, big wine optimization, beverage integrity tracking from grape and wine. And then there are also a few more, actually 3 more use cases or solutions that will not be presented today, but they're part of this fruit trial This is olive oil, automated olive chain, intelligent fruit logistics, and smart trays, and smart overhead spray application. And on top of that, we have enhanced quality certification system use case from the vegetable trial. So I think this is a very good representation. We have here 4 use cases that are looking at wine and grape solutions, and will be delighted to hear about their results. And here I'm sharing with you some communication channels that you can stay tuned, Twitter, Facebook, LinkedIn, and our newsletter, and my contacts at the bottom. If you have any questions about the project or would like to connect, please feel free to get in touch with us. And yes, this is from my side, and I would like to give floor to the next speaker. Thank you.
Thank you very much, Giovanna. So, Gianni.
Yes, thank you. I hope you can see and hear me. My role here is, first of all, to thank George and Giovanna and all the other people who have been brought to the end successfully. I think this project, which has been, in my opinion, very important to show how these new technologies can help agriculture in general. We as Vinidea have been honored to participate and to contribute to a couple of use cases. We will hear today the synthesis of some of them. And it has been for us a very good example on to see how innovation can arise relatively easily and quickly, putting together expertises which are usually not talking each other. When we started the project, we have been always operating into the wine industry, and we know very little about the digital technologies and IoT. And it was hard at the beginning because are really 2 different languages, completely different expertise. And as George was saying, one of the value of this kind of project is that force you or promote the fact of dialogue in between and to find solution to needs which are not normally expressed. So for the wine industry, we will hear today, for example, how sensors and IoT technology can allow decision maker to have a picture of what happens in the vineyard, and then to act timely for water supply or pest management, or to organize labor work, for example. Or we will see how we can have tools to better face the big challenges that our industry has. So the resilience to climate change, the market structure, which is changing with the export share, which is increasing, online sales. And we will see how we can monitor the whole process up to the final retailer through certification, for example, to make our wine more high quality and better transparency and traceability to the final consumer. So I hope that the 6 examples that you will hear in a while will be also for you an opportunity to understand the big potentialities that we have in front of us with these new technologies. And I just leave the word to the speakers because I think it will be very interesting.
Thank you very much, Gianni. We can start the Congress, really. And the first speaker is Vincenzo Verrastro from the Mediterranean Agronomic Institute of Bari in Italy, that will talk us about implementation of IoT technologies along the value chain of grapes. Vincenzo, you have 15 minutes and you have the control of the screen. We are seeing your screen perfectly.
Okay, fine. So I hope that you can see the screen as well as you can hear my voice.
Perfectly.
I will try to be quick and to respect the deadlines of the 15 minutes, even if, as all of my colleagues were saying before, this is a 4-year project. We are at the end of it. And so there is a lot of things to say. And it's quite impossible for me to summarize in 15 minutes 4 years of work at field level with farmers and with the other colleagues. I'm excited, as I said several times, to be part of this crew of these people together. And my work was done on fresh table grapes chain, and our use case, of which I'm leader, were divided between Italy and Greece. A part of it was done in Italy, and a small part of it, due to the budget limitation, was done in Greece. These are the other components, as you have seen in the slide before, that worked with us in the development of the activities. And I will go mainly to describe some of the main activities done in Italian case, considering that our aim since the beginning was to follow the grapes, as I told even in a video that described our work, from fork to fork. So intending, I think in the best way, what was the aim of the IOF 2020 project, EOT implementation at farm scale and in post-harvest. So I will discuss about the blue leaf implementation for the field level in table grapes and for the blow implementation and other IoT at the post-harvest moment. Talking about the fields and the activities we have done during this year, I will go only on the last and the most important ones. What were our aims at the beginning? To upgrade an existing tool with the blue leaf, with intendedly as a decision support system, named for irrigation and pest management. So in the last year, we developed a lot of several new important tools, such as the NFC tags to identify crops and plots and to implement sensor, weather, and station working under the Sigfox network. From the beginning, we follow the Sigfox network for communication tool, not only, as you may see during my presentation, we were even at the Sigfox World IoT Expo in 2017 at the beginning of the project. What is the main aim of the use case? To create an hardware at field level, to use the data acquiring from it on a software, and to give a service in order even to transform the blue leaf, who is already on the market, from a static one, who was something that was only on consultation from the farmer, to a dynamic one, in order to create benefits not only for the farmers in terms of productivity, but also for the environment. I forgot to say that our use case in Italy is dealing with table grapes and is dealing probably with inorganic farming, with most probably one, speaking as an agronomist, one of the most difficult cultivation to do in organic farming. Our closed platform was created to a plot management web interface that through an app was able, for instance, to establish the water balance at field level in an app that is easily understand and managing from the farmer. The last work, the last year, the last couple of years, to tell you the truth, was devoted even to develop a feature who can be even better than a GPS, who is the NFC tags, because it's more accurate than a GPS to localize the crop. In this way, we could have, as you may see in a real picture, some better identification and placement of it. This can be easily used from the farmer to a web app, using a mobile, as mostly of us are using even at farm level today. So the crop monitoring is possible, choosing the right application and having the history of each single crop of the orchards. But why this? This could be probably even something that developed through, let's say, the aspects of the work at field level, because we have at the beginning the complication of working on a large surface. The farm that we selected for doing the farm is probably the largest one in the southern part of Puglia devoted to organic table grapes. And the communication between the data logger was a problem at the beginning of the project. So during the years, we tried to develop a custom solution for IoT sensor using the Sigfox network, introducing the concept innovative as even for our project and for the Blue Leaf DSS of a virtual data logger. This is the virtual data logger. It's an IoT sensor built using a Sigfox RF module that has a low cost because it's based on a thermometer sensor and a microcontroller. The situation that we faced in 2017 was this one. These were the two plots selected. Think about the real size of that entire square part is of parcel whose the average is more or less 4 hectares, but the entire surface is about 80 hectares. So once we place our sensor in a single parcel, we do have only the picture of what was around the sensor, but not the entire parcel of all the farm. The farmer was interested to use the IoT as much as he can in order to be informed about the decision to take once the sensor were installed. So we moved to the virtual data logger using the Sigfox. No, we didn't need more the use of the hardware. We add the information sensors that were immediately transferred to the cloud. And we also solved the problem during these years of extended the battery of the operating sensor more than 1 year now with a decent time for work. And an autonomous online management of the hardware setup was done through this. So the real scenario changed from the 2 ones you see before to the entire surface, which is located in a surface of more than 80 hectares. So the Blue Leaf doesn't work alone, of course. We need only to work with some other tools were installed during the project. The thermohygrometer and part sensor were installed in all the parcels with different varieties that you have seen before. Weather station were installed in over, let's say, the canopy of the crop and outside the parcel in order to have comparison between outside and inside. I've seen that only 3% of the attending today's are working with table grapes, but normally in the southern part of Italy, we have a sort of greenhouse under which we have the production of the table grapes. So the condition and the weather and the climate inside is completely different from outside. We need comparison to do some answer correct using the DSS. And the final one is the subflow, who is able to measure the level of evapotranspiration in general about the state of health, in poor words, of the crop under this kind of controlling. All the information that we get from the sensors and the DSS were, of course, able to connect, to use, to evaluate and better establish when to do the irrigation, which is the best and most important value that we have to follow during the lifetime or the season time of the table grapes. So electromechanical valve actuator were placed all over the grapes in order to establish when and how irrigate and the amount and the total situation. So the focus that we did and the challenges that we won recently was the battery lifetime, the communication technology, the sensor accuracy. We solved all of them, 3 of them, because we installed several of the ones that I've shown before in different parts of our parcels. And the Sigfox communication provides, we saw that it provides an highly stable and great performing technology, and the data were of good level. And there is even, and we established later on that last year, that there is also low latency, not more than 30 minutes, that gave us the possibility to have a real on-time data for working. Now we are moving even to use not only on Sigfox, but even on LoRa networks, this other kind of data, in order to enlarge even the interoperability of different networks. So next steps, because it's still not over, because what happens is that the project for us will maintain our philosophy even after it's ending, not in the new project, but in the developing of the activities we are doing together, because our key aspect is to evaluate what we need for the key factor of table production, which is the evapotranspiration, that in poor words is the level of irrigation. Evapotranspiration is something that can be very complicated for someone who is not in this field, but is based on Kc, which is a constant coming from the Perman-Montet equation, FAO was the basis. We saw that in table grapes, we have published even this data, this Kc can be adjusted. And probably the DSS dynamic version can be able to do it quite soon in the near future. These are some of the new tools that we established. These are some of the data that we recover from the field, able to select potential at field and crop level in order to establish the irrigation. The Greek case...
5 minutes missing, Mario.
We'll go very fast. The Greek case is something that we do very quick in order establishing the field, installing some sensor for humidity, create another platform that was shared even with our DSS. And then these are the common results we obtained in 4 years of treatments using the sensor at field level. But as I was saying before, we are not only stopped at the moment of field activities, we work also in post-harvest in order to elongate the shelf life. We use another IoT, the name is Blow, is a breathing device patented at European level and winning a prize last year. We prepared in a lab scale some of the most important varieties collected from the field that you have seen there. And we tested them in MAP, modified atmosphere packaging, using low temperature and using inertious gas in order to prolong the shelf life. These are pictures of the different types of controlling this kind of blow strategy. These are the testing aspects, and these are the data that I can show very quickly, unfortunately. But what is most important about that, these are the different combinations, the physical and chemical parameters coming from the storage and the prolonged storage of the table grapes. What are the most important results can be, let's say, discussed in this slide. First of all, we have a pre-treatment of CO2 using inertious gas that elongate the shelf life from the normal 30 days until 60 days in the white varieties. We have more days in the around 90 days in the red varieties, the so-called Scarlotta seedless. I should say that one of my wishes, unfortunately someone else did not consent to do it, was to bring at the final event of IOF 2020 the cluster that we collected in September, because 90 days means around Christmas time. And this was the period in which I would like my colleagues, not only from my use cases, but also from the other use cases, to test this and to eat this kind of organic table grapes 3 months after the harvesting. So in few words, I'm sorry that I was so quick to do it, but we can conclude that the IoT challenge at table grapes organic and not was a success. And we did, and we hope for the future to do better and best activities together in order to develop better these activities. These are the names of the people that with me shared the project here at Italian and Greek level. And of course, I'm available for any kind of question that may arise for my short presentation. Thank you.
Thank you very much, Mario. Thank you very much. You stayed perfect in the time, and you almost saved 1 minute for the questions later. So I will say to everybody, Mario presented us a lot of a quite strange name of devices and tools, but in the last presentation we will have Mario Diaz-Nava from ST Microelectronics that will explain everything in detail. So the next two speakers, because they speak together, are Jean-Jacques Dubourdieu from Denis Dubourdieu Domaine and Christian Germain from IMS Laboratory of Bordeaux. IMS is a research lab from University of Bordeaux and the State Research Center of France. So I ask Jean-Jacques and Christian to share their screen. Christian, I guess is your screen to share. Switch on your camera and microphones, and you two have 15 minutes from now.
Do you see our?
Yes, we will see perfectly you, and we don't see Jean-Jacques, maybe.
Our slides are common.
Oh, okay. He's okay.
Yeah, I'm here.
So let's go.
So Christian. Okay, perfect. So hello everybody, I'm Jean-Jacques Dubourdieu. I'm a winemaker in the Bordeaux region and also a general manager of Denis Dubourdieu Domaine. So we had the chance to be pilot in this program. So it was really interesting for us to be part of this adventure. And I will present you our group of family estates. So Denis Dubourdieu Domaine is a group of 6 family estates in the south of the Bordeaux vineyard. So it's a company about 135 hectares, and we vinify in 3 different places. It's a production about 500,000 bottles per year. So we are in the medium size, we will say, in the Bordeaux landscape. We are an historical family in this region. So we also own 2 classified estates in 3 different appellations, so Côte de Bordeaux, Graves, and Sauternes. So it's a medium company, as I told you, so about 40 people, 100% family owned. So here you can see all the history of the family. So my great grandfather Georges Dubourdieu bought Doisiden, which is the most historical estate based in Barsac, Sauternes. My grandfather Pierre Dubourdieu runs the estate during 60 years. My father, Professor Denis Dubourdieu, was also involved in research and enology. He was a professor of enology at the Bordeaux University. Unfortunately, he passed away in 2016. So we continue the family business with my brother since 10 years now, and we were very interested to continue research and innovation to understand better how to make better wine in an environment always more preserved. So we try since 10 years, for 10 years now, to have a very sustainable viticulture. So of course, no irrigation in Bordeaux. There is no irrigation allowed. No herbicide, no antibotrytis. We also are certified ISO 14001, HVE, Haute Valeur Environnementale, Bee Friendly. We also analyze chemicals residue in every bottle of wine. So we are quite involved in all the sustainability and about viticulture, especially at quite a big scale, because I mean we are not a big company, but we are not small. It's not about 3 hectares. So we try in this family business to make efforts every year. And finally, to be part of this program was a wonderful opportunity for us to continue our efforts. So the context is we need more and more precision in our viticulture. We also need more efficiency and a better environment protection. So we, as I told you before, we run 5 estates in 5 different villages with 300 different plots, different soil, different weather condition, of course, different grapes. So we need more information and more precise information. So our expectation are we are expecting a different improvement. First of all, phenology. So what is exactly, at what step are we considering maturity? To be more precise in terms of spraying phytosanitary product at the right time with the right quantity. And also we need more precision considering all these steps to adapt ourselves to the different weather condition and especially the weather risk. So mainly spring frost, wind gust, and hail. Yield estimation is also another important expectation for us. So how to reach the optimal yield. enough for financial profitability and not too much to maintain the quality level. So it's also a way to anticipate the volume before the harvest and to anticipate market evolution, to anticipate our offer with our client. So the yield estimation is quite important, and we need more and more precision and ideally the information earlier and earlier. Health of the vine. So vines are part of our capital. For some reason, we have some grapes quite strong that we can keep for 50, 60, 70 years. And we have also some grapes like Sauvignon Blanc, for example, which are a lot more fragile. We have mainly one disease called esca, among others. And we need more data and more analysis on this phenomenon, which is quite unfortunately increasing. So we need to evaluate the problem more precisely, and we need to know more about its evolution by a convenient way. So it's a big expectation we have on this point, because unfortunately the esca is increasing. Information on about vigor, of course. So vigor in viticulture is quite ambivalent, because we don't need too much vigor because it's a problem in terms of quality, but not enough vigor, it's also a problem because it means there is some problem in terms of viticulture. So to have a precise vision in terms of vigor for each plot can help to choose the right plants, the right rootstock, but also the right fertilization policy and the right way to grow vineyard. So to be able to map the vigor is a very important criteria for us, and it's not that easy manually to have that kind of information.
Okay, thank you, Jean-Jacques. So you have presented us some questions, some issues that arise for the viticulture, and in our lab we try to find some answers to this question within the IOF 2020 project. So the first answer was based on fixed sensors placed in the vineyards for different objectives, such as vigor estimation. On the left side of the slide, you can see the scheme of our sensor and the first prototype of it. In fact, the sensor is based on a low-cost multispectral camera, a low-cost computer, and the computer manages the power and the lighting system in order to provide one image each night, which is processed on board to compute, for instance, the vigor. And then it sends the result of the vigor estimation to the farm management software using a network such as the LoWa network. And all the system is enclosed in a weatherproof housing with a motorized sliding protective shutter, just in order to avoid the destruction of the sensor when you use a sprayer, for instance. So in the next slide, you will see some results we obtained with the sensor. So fortunately, if you can see the video on the left, you can see the growing each night of the vegetation of the vine. And on the right part, you can see the evolution of the curve, which is an estimation of the leaf area index. And you can see that at the end of the growing stage, we go to the maximum value, and then it's decreasing a little bit because we have some vine shoots that are decaying. And you can see the decaying of these vine shoots clearly on the curve also. And on the next slide, if the video wasn't working well, maybe you did not see what I said, but you can see the first picture, one of the first picture at the beginning of the curve, where there is very few leaves. And then you can see on the right side, some at the end of the growing stage, when the shoots are all and the leaves are all gross and some of them decaying, and you can see the corresponding value on the curve. So this is the kind of example of the result we obtain, and the prototype we have provided in order to compute the vigor estimation. Another example of answer we provided was the design of a mobile sensor dedicated to both vigor estimation and yield estimation. So once again, on the left part, you have the scheme which describes how the device work, and you can see a prototype also with two sensors with the lighting system on a tractor. So this sensor is a high-performance mobile sensor. It is based on an industrial camera with a high-power flash, an outboard computer, and of course a GPS for the localization, and all in a dust-proof housing. We put 2 units per tractor in order to monitor simultaneously both sides of the vines. And the tractor goes to its usual speed up to, for instance, 6 kilometers per hour. And we take 1 image per vine. That means probably 2 or 3 images each second.
5 minutes missing, Christian.
Yes, thank you. The images are not currently processed on board, but it's still to be done. It's a problem we will have to address. So some kind of results we obtain with this sensor. You can see on the left the berry detection. It's not yet the yield estimation, but we are able to compute on each plot on each vine the berry detection, the number of berry which have been detected, and you can see on 2 different plots. One where the results are very heterogeneous, and the second one where they are much more homogeneous in a matter of number of berry per vines. So it can help to understand how the yield is done on each plot. Some future works. So we are currently working and have already obtained some interesting results regarding phenology. You have, for instance, here 4 examples of phenology: fruit set, pea-sized berries, cluster closure, and half veraison, for instance. And we have some algorithm that should provide this estimation of this stage. Another future work, which is already ongoing, it's the disease detection. For instance, on the left, you have an example of an algorithm which detects symptoms of SK, which is a grape wine trunk disease. And on the right, it's quite more difficult because it's very small symptoms. It's the case of downy mildew, and you can see some true detection and some error we still have to solve in order to detect as early as possible the downy mildew. Another future work is yield estimation. You have seen that we are able to count the visible berry on an image, but not yet to extrapolate that to the yield estimation. The extrapolation is still unresolved, and it's an ongoing project in another European project that is beginning. We have also some missing vines to detect, and the absence of vegetation is not always the sign of missing wine. So we are trying to use both summer and winter images to solve this problem as accurately as possible. So this was some kind of example of future works. Jean-Jacques, for the conclusion, maybe? Jean-Jacques, we cannot hear you yet. Yes.
So precision is a real issue in innovative viticulture, and this project was a wonderful opportunity to improve our efficiency in an environment always more preserved. So thank you for this wonderful project.
Okay, thank you very much, Jean-Jacques. And thank you very much, Christian. I'll leave for a while the screen with your contacts, but I remember everyone that they'll receive a follow-up email with the contact of every speaker. And even also important is that Italian-speaking people can listen to the translation selecting the Chinese flag on the icon. I'll tell this in Italian if you allow me. Tutti gli italiani possono sentire la traduzione simultanea nella nostra lingua selezionando la bandierina cinese nella sezione interpretariato. So thanks a lot, Christian and Jean-Jacques.
Thank you very much.
Olivier Sommier, sorry, from Ertus Company, which is a software house based in France, to be ready to share his screen and his camera. Okay, we can close this poll. So Olivier will talk us about how to simplify your daily work using Process21, a smart viticulture solution. Olivier,
yeah,
if you're ready, you can share your screen.
yeah. Can you see my screen?
Not yet. Maybe I have to stop. You should be able to do this now. Okay, perfectly. Okay, also for you, 15 minutes. You can go when you want.
Okay, okay. Hi, everyone. Thanks, Jean-Jacques and Christian, for the introduction. I'm Olivier Sommier from Ertus Group, a company which provides the Process21 software. My presentation will be titled How to Simplify Your Daily Work Using Process21, a smart viticulture solution. So my presentation will explain how was deployed the solution. After, we will tackle uses in 3 different cases: vineyards, cellar, and reduction of the environmental footprint impact. In each case, I will explain several applications where you can take advantage of this new sensor with our platform. Finally, I will conclude with the benefits you can get from this solution. The deployment takes place in du Bourdieu domain, as Jean-Jacques explained previously. There are more than 300 plots, so it's very difficult to have a good overview. Du Bourdieu domain are using Process21 for several years. Process21 is a complete web and mobile collaborative app, allowing you to track the data on your wine estate from the plant to the bottle. More than 700 users work daily with Process21. This represents about 22,000 hectares of vineyards. There are 2 user interfaces. The desktop one is designed for managing, scheduling, and advanced operation, while the mobile interface is very useful for daily work in vineyard or cellar, or basic use. There are 3 versions according to the needs of our customers: the basic, standard, and enterprise version, where you can find all the features required for the wine industry. We launch a new module for IoT this year. Sensors do not always transmit directly relevant information. It is often necessary to process the data, apply formulas, create aggregation, calculate averages. That is the job of this new module. So the first step is to deploy your network. You have to install a gateway which will retrieve data from the sensors. A gateway is an hardware that you commit in the internet through your ADSL model. It is also connected to an antenna placed high up, for example, on a roof. After configuration, that's it. You are ready to deploy your wireless and low consumption network. In our case, we deployed 3 main gateways. You will see on the image on the right that the coverage area depends on the location of the gateway. From sensor view, we deployed 9 Davis weather stations, 8 mini weather stations, 19 ambient sensors for Cellars, 28 water meters, 7 electricity meters, 1 fixed camera sensor, 1 mobile camera sensor, and 1 insect trap. First of all, let's look at the management of the vineyard. The first application will be the fight against spring frost. As a sensor, we will use a weather station, but also the weather forecast. We can correct the data with a micro weather station. As they are very small, they can be placed directly in the vineyard at the level of the buds of the wines. Every day, starting in the early afternoon, we will retrieve the data from the sensor and the weather forecast, and thanks to the model we have developed, we will be able to anticipate the temperature reached at sunrise, in red on the graph, which is usually the lowest temperature of the night. Every hour until sunset, the model will update the lowest temperature so that you will be warned if you have to wake up in the middle of the night. In this case, thanks to Process21 Application, you can display on a map the temperature of each sensor in near real time. In fact, the sensors send data every 15 minutes. You can finally make the right decision with real precision. Thus, this first case shows the whole chain from data collection to decision making with the calculation on heterogeneous data coming from sensors and the internet. The second application will focus on phytosanitary treatments. Reducing dependence on pesticides will be a major challenge for the coming years. For example, a decrease of 50% is expected in the coming farm to fork strategy, depending on Green Deal launched by the European Commission. In France, the subject of pesticides has been very controversial for several years now, especially in the vineyard, where 20% of the products are used or only 3% of the agricultural surface. We started working on this 5 years ago to help wine growers meet the challenge of pesticides reduction, and now the sensor will help us to take it to the next level. Our thinking led us to create a decision support system to manage the complexity of the programming of phytosanitary treatments. In the context of precision viticulture, this means spraying a plot only if necessary. With more than 300 plots, like in Dubourdieu domain, it's quite difficult to manage it accurately without dedicated solution. But with less plots, it can be a little bit tricky too. The first step is to define a strategic planning. It starts with the configuration, the disease to be treated, the plot with specific sensitivity to each disease, the pesticides to use, but also the equipment, the sprayer and tractors. As this is a real tool, it manages organizational aspects until it will propose a spraying itinerary. Once all this is defined, the model will calculate the schedule to determine the quantity of product to buy, the time needed, and so on. We will then obtain the schedule with all the theoretical treatments for the next season, as you can see in the picture. At the bottom of the screen, a timeline enables you to navigate through the work schedule to make sure that all the plots are sprayed according to the need of each plot. At this stage, it's possible to calculate several schedules in order to make simulation, for example, on a gradual transition to organic farming, or to evaluate the impact of different weather scenarios. In the end, the user must choose the schedule he wants to use and validate it. The second step is to run the operational spraying schedule. We will launch it for the next campaign. It will start at the beginning of the season. Each day, we will retrieve weather forecast and data from the weather station. Situation from a plot to another can be very different, more or less rainfall, higher or lower temperature, or so on. Accurate data will be sent to the epidemiological DSS. A correction of the result of the epidemiological DSS can be done with the mini weather stations according to the data really observed in the plot. The user can enter the availability of each plot on each equipment. Every morning, the system will propose the most suitable work orders for the current day and also for the following days. The wine grower can accept the proposal, modify the data, and recalculate new proposals. But don't worry.
Più adatta per la giornata e per quelle successive.
Proposition et vous créez vos heures de travail.
At the end, the work
Al
order.
final, la orden de trabajo se mostrará en el teléfono inteligente.
The tractor driver can reuse Process21 as a multi-touch and easy of use console to improve operational efficiency and reduce input costs. The wine grower or the wine manager can consult the sprays in real time or offline to ensure that the work is carried out correctly. This second example shows how the sensor can help to achieve greater accuracy and solve complex situations. It creates added value by reducing cost and optimizing working time. The third case of application concerns insect monitoring. During the season, each insect trap should be visited several times per week. This takes a lot of time. Now, thanks to the connected insect traps, you will receive the information directly on your smartphone in the Process21 application. No need to connect to another application to retrieve the data.
5 minutes missing, Olivier.
Okay. The fourth case is just to show that connected objects can meet special needs. Here you see an innovative Dubourdieu domain building to ensure a correct composting process. From time to time, a standalone Noria aerates the compost. Temperature and humidity must be monitored weekly to ensure that the microorganisms can effectively break down the organic matter. If it is not the case, it will be necessary to restart the cycle of the Noria. If you have specific needs, ask us. The sensor you are looking for probably already exists, and we can integrate it in your app. Let's go now for the Cellular part. The first application concerns the monitoring of fermentation. It's now a basic request to remotely gather the temperature of tanks. For security reasons, you can easily add a CO2 sensor. You will be warned if the level is too high. Like the other sensor, data will be displayed in the same application. Some suppliers are developing connected devices to check the hygiene process. Dubourdieu domains are interested to integrate barrels banks, for example, to the infrastructure. Some parameters you can retrieve are wine temperature, liquid level, cellar temperature, percentage of hygrometry, atmospheric pressure, dissolved gases like O2, CO2, or volatile gases like CO2. For the atmosphere in buildings and other warehouses, you can use this tiny type of ambient sensor. Temperature and humidity are the two most common parameters you can retrieve. Since the sensors are mobile, you can move them around and use them in vineyard in the spring to fight frost, and in building in the summer to monitor the temperature in warehouses. Like other data, they are automatically recorded in the platform so you can get a set of historical data. An abnormal value will trigger a warning if threshold has been set. In this last part, I will tackle the environmental footprint impact. Sometimes regulation requires a lot of documentation to ensure compliance. It is also often necessary to promote environmentally friendly actions and communicate factual data. This action often takes a long time. Connected objects can help in many cases to reduce data access time. The first application concerns water consumption. Use a connected water meter allow to recover a daily water consumption. We can monitor water consumption, record data, create a dashboard, and warn each month if consumption exceeds the value of the previous year. Leak detection will be a powerful tool to reduce water waste. Irrigation of wines was not tackled because it's forbidden in Bordeaux. However, we are working on this subject as part of a project for North America, also with connected devices. The second application is electricity consumption. Like for other consumption, we can monitor electricity consumption, create a dashboard, and warn each month if consumption exceeds the value of the previous year. The last but not least is also energy consumption. It concerns gas oil. This point was not deployed, but appropriate sensors exist. Dubourdieu domain are very interested to continue to add new bricks. It's cost effective as the infrastructure is already deployed and there is no extra communication fees. So my conclusion with Process21 can help wine growers to solve practical and complex problems while creating a reliable and accurate technology they can use every day. We provide appropriate tools to monitor large data sets needed in precision viticulture. We can bring a free-only user interface, and we offer an open and affordable solution allowing the integration of sensors from several suppliers. Thank you for your attention.
Thank you very much, Olivier. Really interesting. So I remember at the end the Q&A session, I asked Stefano Ferrari from the Italian laboratory ISVEA, which is an analytical service provider very developed in Tuscany, but not only in Tuscany, to switch on his camera and to show his screen. We see your screen, Stefano. We are not able to see you by now. Okay.
I think I activated the video.
Yes, we got video, audio, and the screen. So you have 15 minutes from now.
Very good. Thank you, Giuliano. Thank you.
Welcome.
Good afternoon to everybody. I'm Stefano Ferrari. I am the Research and Development Coordinator of ISVEA, a Tuscan company highly specialized in analytical services for the wine growing sector. In this brief presentation, I will show the main results achieved by the development of what we call remote wine analysis, or RWA, an Internet of Things architecture aimed at simplifying the analytical control in wine production, allowing time and money saving during winemaking. This development, of course, benefits from the contribution of IOF 2020 grants, of which it constituted a part of use case 3.2, Big Wine Optimization, started in 2017 and now at its final steps. So you might ask, what is ISVEA? ISVEA is a company founded in 1997 from a pre-existing enological laboratory dating back to the 70s, which was dedicated to daily wine production analysis, standing out for reliability and speed of response. After its foundation, the company has developed a lot in the agri-food analysis while maintaining always a very strong specialization in the wine sector. It has greatly expanded its offer and its customer portfolio, officially accrediting itself for the credibility of its services, as well as obtaining the recognition of many international research institutions. The deep knowledge of the wine sector and the expertise developed by the company over time were the premises for the conception of the remote wine analysis project. Well, transformation of grape into wine is one of the most complex and often also long-lasting in agri-food. And this transformation process is the original context of remote wine analysis. many variables can affect the quality of the process, and therefore they must be kept under control. But one of the fundamental control strategies is to frequently monitor the basic chemical composition of the product. We have to keep in mind that frequent basic composition control means in certain periods of the year, multiple daily assessments to monitor the more or less fast transformations taking place. Of course, in other periods, these assessments must be anyway processed, although not that frequently. In a small or medium small winery, it involves transfer of samples to an external laboratory that entails significant costs, energy consumption, wine waste, but above all, a lot of time, often to the detriment of other tasks, since in a small winery, a single person can have agricultural, enological, commercial, or administrative tasks at the same time. This ultimately results in less frequent checks, therefore in increased risks. On the other side, in medium, large, or large wineries, there's often an internal laboratory led by specialized technicians using either dedicated methods, which require long times, high expertise, high reagents in wine consumption, or multiparametric instruments, which have high costs, require frequent maintenance, have sometimes little known database consistency, depends on which kind of instrument. But finally, anyway, need good skills by the operators. Often the use of multiparametrics can become self-referential, where cross-checks with use of dedicated methods are not carried out frequently enough. Then also in this case, we're talking again about high costs and time wastes. And if the winery size also involves a considerable team, a tiring activity of exchange of informations and instructions. The project of remote wine analysis, as it was developed by ISVEA and Vinidea, has the objective to simplify the activity described so far, reducing the associated time waste and costs. Its IoT basic concept consists in a flow of data that takes off and lands in the cellar. Certainly around it, some requirements had to be met in order to be implemented efficiently. As first, the choice of the appropriate analytical technique is strategic to generate a rich enough data source. It must be repeatable and must require no or very little sample pretreatment. Another preliminary requirement is the availability of a reader, which means a detector, properly aligned with the already operating pool of instruments present in the network. Actually, the most appropriate technique appears to be the spectrometry or spectrophotometry. But as said before, at the same time, it's very important to be in the condition to work on undisturbed sample. Then it's fundamental to develop a processing algorithm robust enough to reduce the average error to a significantly lower value than the uncertainty of the reference method. ISVEA has the opportunity to analyze every year over 100,000 wine samples originating in every part of Italy and many wine areas of the world. Moreover, we can carry out most of the determinations with dedicated and accredited techniques in accordance with UNI 17025 standard. Finally, once the source data are processed in the cloud to generate the desired parameters, these shall be made available to the whole winery team in real time to take immediate decisions. This must happen as quickly as possible from data acquisition with the least time waste for the operators. So, this was the idea. Moving on to the concrete implementation of the concept outlined, the strategic choice of the detector fell on the best available performance to cost ratio that we found on the market. This being the TDI Assemble FT-IR spectrometer, which is a very high performance detector. It allows a huge information content, high repeatability, easy alignment, easy maintenance, little or no sample treatment, and last but not least, a small sample quantity, and it's very fast and time saving. Here it is. In 3 years, ISVEA created a database of thousands of samples that have been counter-analyzed for 9 basic parameters using reference analytical techniques. Furthermore, new parameters that will fit with the detection technique will be implemented and made available on the platform over time. Platform, which of course represents the key point of the IoT architecture. Wenda is a powerful platform dedicated to the management of data connected to food traceability. Wenda was already present in IOF 2020 for other aspects relating to wine. It was therefore the natural partner for the construction of the remote wine analysis architecture in the cloud and for the development of the application dedicated to the end user. On the screen displayed in the slide, you can see the results of a sample read in triplicate, shown a few seconds after the actual processing. The high repeatability of the results is well evident, and the up highlights the unreliable sugar value of the two reported by representing it in red. After all, a value of about 40 grams per liter of sugar can be fitted adequately by a low sugar calibration algorithm. The composition of the analyzed wines is immediately shared with each colleague of the team who has the app on his device. So let's take a look to the whole system, the whole IoT solution.
5 minutes, Stefano.
Okay, thank you. I will close in time. The winery system represents the starting and ending point of the information flow. Here, an operator who is not required to have a particular level of specialization frequently reads and generates spectra of grape, must, and wine samples, and sends them together with spectra coming from many other wineries and laboratories in the world to the cloud resident platform, where ISVEA's constantly evolving calibration functions are applied. Of course, the continuous data supply from all over the world not only gives support to make the calibration of parameters more and more robust. From the elaboration of this data, very interesting comparisons between different areas or wine growing conditions can be derived, as well as a definition of characteristic benchmarks. On the other hand, users benefit from an important alignment effect of analytical data between laboratories and wineries, even from different continents. The results are then sent back to the winery teams, who can be instantly informed of products composition, compare and follow the evolution of wines, take decisions and share them in real time. Everything turns according to the speed of the work in progress, and without taking time away from the job, everyone immediately receives the parameters on their app and can elaborate them to decide if and how to act. So, I think I'm largely in time. I remain, of course, available for any question about remote wine analysis you would like to ask at the end of the webinar. Anyhow, laboratories would like to join the ISVEA remote wine analysis network contributing to make the database stronger. For example, in regions where ISVEA would hardly be directly present, as well as wineries, of course, can directly ask me whenever they want for information, mailing to my account displayed in the slide, which has disappeared. Here it is. So, thank you very much for the attention and good continuation.
Thank you very much, Stefano, not only for respecting the timing, but also for the information you provide us and the very interesting technique. I'll briefly introduce also the next speaker. We can close the poll. Thank you very much. And I'll ask Francesca Romero from Valore Italia to switch on her camera and to share her screen. Valore Italia is an audit body, certification body working for many Italian appellation of origin. And Francesca will speak us about the Internet of Things tools to enhance and strengthen the certification of quality wines. Francesca, as your colleagues, you have 50 minutes to talk. You disappeared right now. We can see your screen, but not you. Francesca, please say us something. We see your screen. We see
okay, I'm here.
Okay, great.
You can see me?
Yes.
Okay, and you can see my screen?
Yes, you can put it in full screen mode if you want.
Okay.
We hear your voice, but we don't see your face. It's a pity, but anyway, the important thing I think is to hear you. But
okay, maybe I try to activate also my. Okay, now you can see me.
Yes.
Okay, thank you very much. Sorry, but I had some problem.
Doesn't matter. Okay, 50 minutes for you as your colleagues.
Thank you very much, Giuliano. Good evening to everybody. I will present Valore Italia's use case within IOF 2020 project. The title of our use case is IoT tools to enhance and strengthen the certification of quality wines. Why did we choose quality wines and what do we mean with this term? Quality wines include both PDO and PGI wine, so protected denomination of origin and protected geographical indications, and also organic wines. And we choose them for two main reasons. Firstly, because wine is the most regulated product in Europe, and in Italy there are more than 500 PDO, PGI types of wine. And secondly, in order to have two different methods of certification approach. Process certification in the case of PDO, in the case, of organic standard, and product certification in the case of PDO conventional wines. But who is Valore Italia? Valore Italia is the main control and certification body for wines in Italy, and we certify more than 80,000 PDO, PGI conventional wine companies, and also more than 2,000 organic operators. Here you can see also some different logos because we provide a wide range of certifications such as integrated production or sustainability certification such as Equalitas. But regarding the wine certification, we every year we inspect around 12,000 vineyards and cellars. We sample more or less 50,000 wine samples because every wine bottle that you can find on the market has been certified and analyzed by a control body as we are. And we certify and control from the grape to the bottle until the issuing of the government seal, the government label that you can find on the neck of the bottle. But which were our needs that brought us to participate in IOF 2020? As a certification body, we need to manage a lot of data, and they are often managed through different databases. For this reason, the auditor had a lot of paperwork to prepare in the office before the audit. And the photo here is an example. And there was also a big risk of mistake during the audit due to the manual filling in of the audit report. And consequently, there was a low efficiency of inspections due to the impossibility to access databases in real time. But for this reason, we decided to develop 2 applications for smartphone or tablet, which is now the most popular smart device, in order to have the audit report to fill in directly on the tablet and have the connection to all databases needed to consult data in real time during the audit. We also introduced virtual reality as a training tool for inspectors, but I'll come back to this point later. Starting from the vineyard audit, the inspector has to understand the right position of the plots under control, and all the cadastral data, such as the kind of vine variety, the surface, the area, and so on. So everything that is registered on the national database in order to check if it complies with the reality. And for the organic control, it is also compulsory a check on the farm logbook in order to control the historical agronomic data, agronomic practices. Here are listed a lot of databases used in this kind of control, so you can imagine the challenge to connect all of them with our database. Something is still to be refined, but we are in the final phase of the project. And here there is a sort of example of our application for vineyard inspection. So how it looks like. There is, as I mentioned, the report of the inspector to fill in, the connection to geographical information system, and 2 other cadastral data the inspector needs. And what about the cellar control, the cellar audit? The on-site control in the cellar provided the auditor checks the correspondence of wine stocks, comparing the reality with our database and the national logbook. You must understand how much and which kind of wine there is in the various barrels and vats. And for organic standard, he has also to know the enological practices that have been done in every lot of wine. Here, there is a screenshot of the so-called CIAN, the Italian National Logbook, that has become digital since 2017. So it was born together with IOF 2020. And it is a cloud where all wine companies store their data. And here you have an example of how our database looks like. It is called Dioniso, and here are registered all certification steps and documents. And here you can see an example of the application for the on-site inspection in the cellar. In this phase, we also tested the augmented reality framing with the smartphone, a QR code on the barrel, and having the data shown immediately on the tablet. But the final result was not so valuable for the auditor, so we stopped the testing phase of this part. more interesting was smart sensors to apply on bats. Thanks to a Portuguese startup, WineGrid, that had already developed the technology, we tested the sensor available in 3 different versions. The sensor can be applied on barrels that measure the level and temperature on the barrique, or the density and temperature on barrels and vats, both. It is also available a sensor that for the remote and real-time monitoring of wine fermentation. So this real-time measurement helps the winemaker to follow the kinetics of fermentation, visualizing the precise moments for new interventions. And as I mentioned earlier, we tested virtual reality, which could be a training tool, a good training tool for inspector, because we can offer the compulsory annual training directly from our office, saving time and money. After the pandemic situation all around the world due to COVID-19, this tool is also a useful market tool for wine companies. They can offer to their importers, for example, a complete guided tour of their cellar directly from the other part of the world. Or, for example, they can invite their customers for a 360 degrees tour of the wine company, also during a fair such as Vinitaly, ProWine, and so on. And finally, I will tell you about the pros and cons, starting from the difficulties that we had to face. The interoperability among databases was not so easy and immediate due to different situations in Italian regions. More or less, every region has its own database, so you can imagine the challenge. Another difficult aspect was the connection among sensors in rural areas. We tested different kind of connection, but taking into account the rapid evolution of this kind of things. For example, at the beginning of the project, the 4G, the connection 4G was a new innovation, and now there is already the 5G.
5 minutes, Francesca.
Okay, thank you. I will end soon. But concerning positive aspects, we reached our goal of reduction of paper and human errors. So when this project, this pilot will be at full capacity, this could really improve the efficiency of our audits. Now we are still in a pilot, we are still in a testing phase, but we believe that this will change our daily work. And finally, yes, considering the pandemic situation that there is still all over the world, what we developed became urgent and fundamental. For example, last March, there was even a EU regulation which stopped any in-person audit. So now we are still in a difficult phase. And for this reason, any safe and secure solution to run in-person audit remotely is welcomed. So here are our contacts. If you want any further clarification, we are available. My colleagues, Matteo Barleracchi, the use case leader, and Andrea Zaffonato, the IT manager of Valor Italia, will be at your disposal for questions. And thank you very much.
Thank you very much, Francesca. Very interesting tools. And also for these tools, I'll share just a while my screen just to remember all the people that all the recordings of of this presentation, of this speech, will be available on InfoWine in the next weeks. So if you are not registered, please do it. It's free, it's in 6 languages, and you can get a lot of useful information from Grape and Wine world. And all the contact of the speaker will be available in a follow-up email. And then we will move to the next presentation that will be done by Mattia Nanetti from Wenda, which is a food tech company, Italian startup. And Mattia will talk us about collaboration and traceability in the wine supply chain, a platform at the service of the sector. So we can close the poll. I can ask Mattia, he's here. So you can share your screen. Okay, we see your screen, Mattia.
Can you see my screen? Perfect.
Okay, so 15 minutes for you two from now.
Yes. So nice evening to all. Thank you very much for this opportunity. I'm here. I'm Mattia, as you can read, and as Giuliano said, I am the co-founder of Wenda, that is a startup, food tech startup, and we will present something that was reached also thank you to the IOF project funding and network. Thank you very much also to all the components of this amazing project. So Wenda is an expert startup backed by international investors that have headquarters in Italy, but international operations. We have a proven international experience in the wine market for temperature, data monitoring, and tracking. Having started our business with a patent for temperature condition monitoring 5 years ago, and having led and coordinated the use case 3.6 within IOF called Beverage Integrity Tracking. This project is involving more than 50 companies and have great partners such as Vinidea, Sive, Isvea that already presented, Vinidash, and Highclere Consulting. We are here to present you how to take the opportunity to not waste efforts made in the field or in the cellar, because we have seen how the wines can be subjected to bad temperatures while traveling around the world. But also lack of temperature control can happen in the cellar, and visibility there of product integrity is also crucial. Basically, for avoiding the devaluation of your brand, missed sales, and damage to product quality. As you all know better than me, wine is a living product. I mean, we push a lot to don't make it ruined just because there is no visibility, or you think there is no possibility to have visibility in the entire supply chain. It was also said farm to fork. Take the chance to protect it. We have created Wenda, at the moment the only collaborative and universal platform for managing, controlling temperature and traceability data from farm to fork, supporting different IoT devices, measuring tools and systems that help you gain real-time temperature monitoring and tracking from the cellar actually to the wine shop, getting loyalty from your customer and also brand storytelling to enhance collaboration while embracing the opportunity of digitization, which is very, very important nowadays. Companies can subscribe to different software models that can bring visibility and data management to specific supply chain processes. For example, the shipment, the storage, the analysis, as also said by Stefano of ISVEA, and so on. If the company doesn't have IoT devices or data loggers or measurement tools, we can provide it to the company itself by third parties. We can resell it to supply this. But if the company already if you have monitoring systems or IT system in place, we can seamlessly connect to them via simple and very plug and play API. Let's have a deeper look on the WEDA modules. To start, I want to start with an example and a question to you. You know everything of your child, right? Until he or she stays at home. But the question is, when it leaves, he or her leaves your house, and when your wine leaves your winery, with the shipment module, we'll let you check the condition of the goods in transit, from the temperature to location to the humidity to the humidity sensors, enabling you to save money by optimizing logistics, avoid product losses, which is very important, and monitoring logistics performance and automating controls, even if you are not responsible for the goods that are delivered, because the brand on the bottles is yours. Plus, we are linking the possibility with an insurance policy, an insurance partner of an insurance policy to protect by bad handling in the shipment, which is not only broken bottles, but also heat damages. And so this is very important because the wine, as you all know, can follow very, very different paths. And it is crucial to not make it ruined just because we don't have visibility on the shipment. But taking a step back in the supply chain, consider again the child example. Still, when your child is at home, you have to have control on him or her, right? Here we are. For the aging barrels or stored wine, we help you digitize the control of the temperature and humidity of it. Check if the aging cellar and the correct functioning of, for example, the refrigeration system of your house, while saving time and product quality in doing this. Also here, we are linking an insurance policy for this specific case. And if there is already a monitoring system, very happy to connect to it. We are agnostic from the IoT hardware point of view. Then, as already mentioned by Stefano of ISVEA, with the NetTest use case 3.2, we are part of the platform that is behind the analysis module, offering this module for speeding up and digitizing the analysis process. For all the modules, it is important that you can control, visualize, get reported, and manage data from mobile app and web app, choosing from a wide range of supported data loggers and measurement tools, also yours. I want to make a focus on the mobile app. We developed special functions within IOF 2020 project, use case 3.6, allowing a direct connection between retailer, so the wine shop, and the producer, making the retailer receive both marketing content directly produced by the winery and, if needed, temperature data to the producer for those shipments that are not controlled with a real-time technology. Finally, very important, it helps the producer receive direct feedback from the retailer on product issues, because both of them normally have no chances to reach out to one another. Sometimes they even don't know who they are. So let's see what some companies discovered with Wenda or are saying about it. First, let me say why we are unique in the landscape. We basically put together in every single software module that I presented you different measurement tools. And as you can leverage with the same platform on different modules, you can have an end-to-end approach for visibility on your product condition. And as per we can onboard on the platform, your client, his client, up to the wine shop, we basically are able to have a real farm to fork visibility. We are not all working only on the wine, but on the wine with the bottles, but also with the grapes. So, I mean, we are a collaborative platform, an open platform that can connect with different systems, delivering analytics, not only raw data showed on a software. So
5 minutes, Mattia.
Yes, thanks. So going to some case, a first company, for example, discovered their courier did not maintain temperature-controlled transport, with the risk to compromise wine quality, brand image, and sales. Another company delivering to Russia had crystallization on the bottom of the bottles that compromised quality. And another case showed how delivery to Asia could be very, very risky. All three are showing how the monitoring system that guarantees full visibility all along the chain is needed to secure, from one side, maximum product quality to customers all over the world, and more efficiency, the chain itself. Still, for example, in the IOF project, the use case 3.6 users showed how interesting and useful is the system for their daily work, and how it has been useful to them. Again, in the project, we worked with more than 50 players in the industry, tracking dozens of shipments, and understanding how also the mobile app that I presented before is useful to directly connect the wine shop with the producer. They both are too many times disconnected and don't know much on the product conditions. Then I want to present you another case, going to the end, of a wine distributor selling to Asia, connected to an auction house, and we are helping their export and logistics department to take care of the wine, both in sea and air shipments, discovering bad treatments of the product, changes of plan in the delivery, making delay, and ensuring a perfect final quality. Also for those kind of product going so far, such as in inland China or Hong Kong. And we are looking on how to give visibility on the warehouse. Other case in which the producer of very good wine shipped from South to North Italy had advantage having a look on the ground freight transportation. So not only internationally, bad temperatures can happen. Last case I want to present you is another player that have not only used the Wenda system to take care of the quality of his product, while managing the risk of losing potential revenues, but look at the possibility to use Wenda as a sales leverage towards the import in the US. In the end, to conclude, we are here. Don't miss the opportunity to embrace innovation, as all the cases before also presented. And here, to embrace innovation, to gain visibility on your product condition along the entire supply chain. Don't hesitate to reach out to me or my colleague Andrea, that is in the slide. And thank you very much.
Thank you very much, Mattia. And I ask Mario Diaz-Nava of ST Microelectronics, which is a very famous company. No need for introduction to talk us about the infrastructure behind the IoT smart system to reduce wine entrance, handle cellular complexity, and improve wine quality. Sorry, Mario. We see your presentation. I can't hear you right now. Neither see you.
Okay.
Okay.
Do you see my It's okay?
It's okay now.
Okay. Okay,
So,
my name is Mario Diaz now. You have the full screen?
We see it in the presentation mode. You should be able to switch in the in the other mode because we see the next slide also.
Yes, it's okay.
Yes. Okay.
Okay. Sorry,
So,
I don't know why it's okay. Okay.
15 minutes from now.
Okay. Thank you. My name is Mario Diaz Nava from ST Microelectronics and a semiconductor supplier. Why I am here? Because we are provider of IoT solutions from hardware point of view. Okay. Then I think it's really important if we want to have a successful system based on components that are performant and very integrated. Then my role here in this project is I am the coordinator of the use case Big Wine optimization, and I will present the IoT system infrastructure that we have developed in this use case, and more is to go more in details about what is an IoT system. And my presentation is divided in four parts. The first one is the context, IoT in viticulture. The second one is IoT brief system overview. The third one is IoT for wine growing and production. At the end, I will make a takeaway about what is IoT and technologies and benefits for the users. IoT in viticulture. We have already mentioned in the previous presentations the needs of a more precise information. Data collection is very important. We need tools and we need problems, and that we need some solutions. Here, according to wine industry needs, we have weather forecasting and weather conditions measurements need more precision, considering vineyard locations. We need to manage many sites, and data with few staff is hard. Optimize wine production, preserving its quality is fundamental for keep competitiveness. Optimal management of resources is a key economical factor for small and middle wine growers. New legislation and standards request to preserve the environment and ensure sustainability. Some objectives has been defined to reach and to answer to these needs. The first one is improve the wine yield by introducing precision viticulture techniques based on an IoT system. Deploy a cost-effective precision viticulture management and a global vineyard control system in order to handle complexity. The third one, optimize the use of inputs of winemaking by controlling all environmental factors affecting the process, temperature, humidity, oxygen, etc. Provide the middle and small wine growers and producers new tools to optimize resources, manpower, fertilizers, materials, electricity, water, etc. Preserve the environment for reducing the use pesticides, carbon print, and others. I think in the previous presentations, we have already mentioned these objectives. Some solutions has been developed in the other parts, in other projects. I think I will focus my presentation more in the hardware part, more what is IoT system and the different parts that are an IoT. Then this is my next section is brief system overview. What is IoT? In fact, IoT is Internet of Things. It's a monitoring and control system. This IoT is an evolution of existing monitoring control systems. We cannot say that IoT is new. This exists, but less flexible with many constraints to perform control and monitoring. And this one of the big interests of IoT is to bring new technologies that will revolutionize the applications. And this is in many industries, in many areas, this will be applied, this scheme. This go for digital industry, digital farming, transport, and smart mobility, etc. Bringing high flexibility, accuracy, precision, distributed computer power, and at cost effective. What is this system? This system is based on 4 main parts. Sensing. Sensing, we will have the capabilities to sense the environment thanks to the sensors. To bring these sensors will give you a lot of information that we can give you more precise solutions. Thanks to what? To put intelligence in the algorithms, that we will get data analysis. The results of this data analysis will be allowed to take decisions, more precise decisions at any time and anywhere. Finally, with these decisions, we can control the rest of the systems. Could be the machines in the vineyard, robots in the vineyard, decisions in the cellars, etc. This is more or less what is the 4 main aspects of a smart system that could be applied everywhere. Then in more details, then this is, I will present here the reference of the IoT architecture. This is 3 main aspects, 3 main domains are included in IoT architecture. The first one is the edge, when we recover the data. Many of the things that are in this edge domain are what we call constrained devices. Could be sensors for temperature, for rain, for pressure, barometric pressure, bulbs, or we can more complicated, more intelligent ones like robots, drones. An autonomous car is also, we can say that is a cyber physical system. Satellites also, we have also smart devices like the smartphone. All these devices send information, a lot of information to the cloud, that in the cloud, this will perform the data analysis. In the current technologies is based in artificial intelligence, machine learning, deep learning, that will help to the users, to the applications developers to take the algorithms to make some applications. At the end, we have the applications. Most of them for viticulture has been already presented in the previous presentations. In more details, in concerning my company, because we are providing this kind of technology, but is an element very important, is what we call the end devices. What is the structure on edge devices? An edge devices is what we call currently a smart object or unconnected object. These objects are constituted of 4 main blocks, we can say. The sensors, temperature, humidity, barometer pressure, rainfall, wind speed, but could be also water meters, electricity meters, and many others. We have generally a microcontroller that will be prepare the data to be transmitted through a protocol, to a transmitter. This transmitter could be taking different protocols. We have already mentioned the first presentation to using Sigfox as a protocol, but could be also using LoRaWAN network, or could be used GSM, 3G, 4G, 5G, NB-IoT. This depends on what we want to do. Another very important aspect is power supply and management, because many of these objects are working on their battery or with harvesting technologies, and really is very important to what. Very important aspects in this is autonomy. We cannot change the battery every time. It's cost and take a lot of time. Then we need to be autonomous. We need to increase the battery life, and this is why important. Power management is really important. Large coverage in a very, very important aspect in agriculture. We have hundreds of hectares that we need to cover, And this is only possible if we have a large coverage the transmission. Integration, these subjects should be small because will be deployed in the field and the machines could be destroyed. Then they will be really integrated. Of course, if we need to be the low cost if we want to deploy a large number of these devices. And for sure, they should be robust. From the other side, what I have already mentioned, we need the transmission. These objects with a standalone are not interesting. They need to be connected to the, we are talking about cloud. We say that it is communicate with the cloud, but there is another technology, another, how to say, orientation is to make all in the edge and to eliminate the cloud. For many applications, it's not necessary to send all to the cloud. Many things could be to make in the edge, and we call about edge computing. Then we can eliminate many things there. Then here what we have the interface between the smart objects that we are working with different protocols, and then we need to have the processor will be used like protocol translation to go for an IP protocol that will be allowed to connect through the different medias, could be twisted pair, ADSL, VDSL, and optical fiber could be the RF, 5G, 3G, etc. to the cloud. Then
5 minutes missing, Malio.
Okay, thank you. Then here we need this kind of also devices to complete the communication between the smart objects to the cloud. Something that is really important is to take into account that which kind of network we need to develop. We have different kind of protocols. We have to take into account the reach of each of these protocols. What is the data rate, the power consumption? It is used on telecom operator system or the service cost. This is the different elements that we need to take into account. In our solution, we have select LoRa because have a large reach. They can send a small amount of data, is low power, no telecom, is for free. Then IoT wine growing production, this is the solution that what we have deployed in the use case being wine optimization. We have the edge domain. I think my colleague Olivier has already presented the different sensors that we have. We have the cloud. In the cloud, we have the LoRa server. That is, the LoRa server is to allow to control practically all the devices, the subscription. They also receive the information coming from the devices and send to the sensing act, and IOF is the middleware that would allow to encapsulate the data put in the database, allow to be available for the data analysis and applications. Then I think we have mentioned, we have this LoRa network deployed is in 5 domains, covering more than 70 end devices. And finally, I think the lesson learned on this use case is that we have here a picture of the complete solution covering the wine growing, the different infrastructure to use for wine growing and production. And the main things that we have learned is what? We need high autonomy from the IoT devices. We need to have large coverage because it's in viticulture and in the agriculture in general, you have a lot of big extensions, high integration, low cost, robustness, reliability is essential if you don't want to lose data. Easy to use is fundamental. The end users need to easily understand and manipulate the information and provide it. Availability all the time. Flexibility, the possibility to introduce new sensors, the possibility to integrate new applications. Support and maintenance is essential. Without support, it's very difficult to introduce this kind, and maintenance is very difficult to introduce this technology because people need to be there. Finally, we have also here the main benefits of this solution. It is an holistic IoT decision-making system. This is from the custom point of view, is easily replicable for other viticulture uses and other agricultural use. It's a complete chain that we are providing from the vineyard to the put in bottle the wine. Then you can put many other sensors in this chain. It's easy to do. It's also the decision we have taken is not to pay communication. This is thanks to the LoRa protocol. This you can create a private network. And finally, this provides hardware, middleware, decision-making software sales. This is to make business. And in conclusion, the key technologies, advanced sensors, multi-sensors, and cyber physical systems are key for IoT systems. Data analysis that is doing, you go for not complex algorithms until using artificial machine learning, deep learning at the edge, as I have mentioned, and the cloud using edge and cloud computing techniques. Cybersecurity, for sure, we need to introduce. Interoperability to interact with other systems, easily integrate and to have complex solutions. Ultra low power solutions, we have already mentioned. User requirements, low cost and robust solutions. Friendly user interface, support and maintenance are key. What are the benefits? Handle complexity, improve quality for any kind of products, optimize inputs and resources. Finally, and not the least, how IoT electronic component and systems can contribute to reach European Green Deal goals. It's really important. This is farm to fork. We need to target to reduce entrance. We need to reduce pesticides. We need to go for more we need to move from conventionals to more organic solutions. Thank you very much for your attention. You can contact me here. Thank you.